To this video series on computer networking. Today we are going to explore the basics of networking, including networking architecture, communication protocols, performance evaluation, and security. So by the end of this session, you will have a clear understanding of how network functions and how they stay secure. So let's get started. So what is networking? Networking in computing refers to the practice of connecting computers and other devices to share resources and communicate. So the internet is often called and referred to as network of the networks. So basically, internet is a vast global system that interconnects millions of smaller networks, including private, public, academic, business, and even government networks. So in internet, the interconnected networks are communicated using the common protocol, which is called the Internet Protocol or IP in the short form. So the most commonly used internet network, as you all might already know, is LAN, which is also referred to as local area network. So further in this video series, we will learn more about network architecture, communication and protocols in networking, evaluating network performance, and lastly, securing the networks. So let's begin with network architecture. So a network is made up of several components that allow devices to communicate and share information. One of the key components is the network edge, which is where devices connect to the internet. This includes routers, switches, and firewalls. So as we speak about network edge, let's talk about host, clients, and server. A host is any device connected to the network, which can either request services like a client or provide services like a server. For example, when you use a web browser to visit a website, your device is acting as a client, while your website server responds by delivering the content to you as you request it. So example for the server is like a database where you get all your requested data from. Now let's talk about access networks. An access network is a type of network which physically connects an end system to the immediate router, also known as the edged router. So there are three different types of access networks here. The first one being home access network. Home access networks are common in the household. So these include like Wi-Fi routers and Ethernet connections. Whereas enterprise access networks are found in businesses, schools, and offices and organizations. These networks use LANs and VPNs and firewalls to provide secure and stable connectivity. While mobile access networks provide internet connectivity through cellular towers and mobile data servers, enabling wireless access on the go. Moving on to the next section, let's discuss about the network core. So the network core is referred as a mesh of routers that interconnect the internet's end systems. Network core is also known as the backbone of network. So the functions of network core is quite important as it is clearly evident that it also involves in forwarding and switching that involves in moving the packets from input links to the output links, whereas routing determines source destination paths taken by these packets. Let's talk about packet switching and circuit switching. Packet switching is a method of data transmission where data is divided into small packets and that are sent independently over the network. Each packet contains the destination's address and can travel through different paths to reach the destination. So the key features of packet switching is efficient utilization. It has no dedicated path and flexibility and also capable of error handling. Whereas speaking of circuit switching, it is a method of communication where dedicated communication path is established between two endpoints for the duration of the session. This path remains reserved and provides a constant bandwidth throughout the communication. So moving on to the section 2 of this video series, we will now discuss about communication and protocols. So for smooth and secure data transmission, networks rely on communication protocols. A protocol is essentially a set of rules that governs data, how it is sent and received. So communication protocols are basically used for data formatting, error detection and correction, flow control, addressing and routing, session management, and also even for security. So as we are talking about communication and protocols, we must discuss about HTTP. HTTP is basically Hypertext Transfer Protocol, which is the fundamental protocol of the Internet, transfers between a client and a server. So foundation of the data communication for the World Wide Web was established by HTTP. So it provides a standard for web browsers and web servers to establish communication, allowing the transfer of data such as texts, messages, pictures, and other multimedia files. So as you can see from this slide, is a link that is an example of a HTTP protocol. Now, talking about TCP, which is translates to Transmission Control Protocol. It is also one of the fundamental protocols within the Internet Protocol Suite, and which is responsible for ensuring the reliable and ordered delivery of data between applications running on hosts communicating via an IP network. Example for this TCP is your web browsers and email functions. So all these run on using the TCP protocols. So with this, we conclude our communication and protocols section of this series here. And now let's move on to the next section. So now let's discuss about network performance. So network performance is crucial for ensuring a smooth online experience. There are three factors that determine how well a network functions. So let's talk about packet loss. Packet loss occurs when some data packets uh, fail to reach their destination, often due to network congestion or hardware issues. High packet loss can disrupt communication and cause incomplete data transfers. Latency or delay. So latency or delay, this refers to the time it takes for a data packet to travel from the sender to the receiver. Uh, this high latency can cause noticeable lags, which affects real-time applications like video conferencing and even online gaming. So throughput is a measure of how much data is successfully transmitted over the network per second. Higher the throughput means better the performance and the faster the data transmission. You see this slide, we are going to talk about packet queuing, packet loss, and transmission delay. So packet queuing refers to the process of arranging data or tasks in a sequence or a queue to be processed one at a time. Queuing helps in managing resource allocation efficiently and ensures that each task gets processed in organized manner. In network communication, queuing can help manage traffic by prioritizing certain types of data over others, reducing the delays and improving overall performance. Transmission delay, transmission delays and improving overall performance. Transmission delay refers to the time it takes for a data to be transmitted from source to the destination. So this delay can be caused by various factors, including the distance between the sender and the receiver, the speed of the transmission medium, network congestion, data, and even the packet size. Transmission delay is crucial in network performance and can impact the speed and efficiency of the data transfer. While speaking of packet loss, it occurs when one or more packets of data traveling across a network fail to reach their destination. So this can result in loss of information and reduced quality of service, especially for real-time applications such as video calls, online gaming, and even streaming. So from this diagram, as you can see here, uh, Senders like A and B are sending their packets over the transmission medium and that are being transmitted to their destination. So these, so there are packets in buffer that can cause queuing delay, and packets that are queuing up can also cause transmission delay. So if there are no free available buffers or slots, and then we can experience the packet loss. That means the packets without free buffers can be dropped in the network. You can see from this diagram on this slide, you can see the transmission, propagation, and nodal processing times that are clearly stated out here. So D nodal equals to D processing plus DQ plus D transmission plus D propagation. So transmission delay means it refers to the length of the packet in bits and the transmission rate, which is in bits per second. So the propagation delay could occur depending upon the length of the physical link, that is the transmission medium, and also the propagation speed. Now, we are moving on to our final topic in this video series of computer networking. Now we will be discussing about securing the networks. Let's talk about encryption. Encryption is a method used to protect information by converting it into a code so it can only be read by someone who has the key to decode it. This process helps to ensure data confidentiality, integrity, and security, making it a crucial tool for safeguarding sensitive information. Encryption is important for security, data protection, secure communication, and also even compliance purposes. Authentication in network security refers to the process of verifying the identity of a user, device, or entity before granting access into a system, application, or even a network. So it ensures that only authorized individuals or entities can access certain or limited resources or information. So it is important to have authentication in place to ensure compliance, security, and data protection. So network security is a vast area to cover, and we will be talking about two important terminology and topics in this network security area, which is IP address spoofing and packet sniffing. IP spoofing is a technique used to disguise the true source of Internet Protocol packets by altering the packet's IP address to appear as if it's originated from a different address. This technique is often employed by the cyber criminals for various purposes of malicious practices such as launching distributed denial of service attacks, bypassing network security measures, or gaining unauthorized access into the systems. Whereas, as you can see from the picture here, packet sniffing is the process of intercepting and analyzing data packets as they are traveling across the network. It is commonly used by network administrators for monitoring and troubleshooting network issues, as well as cyber criminals also use packet sniffing to gain unauthorized data access and encryption. So how can we be, as an individual and an organization, be safe and secure from such these cyber attacks, such as IP spoofing and packet sniffing? So, well, there are certain key strategies that could be used to improve and provide network security. As we can see here, zero in on user identity by centralizing security control on both user and service IDs. We could also use multi-factor authentication systems where we can safeguard the network security and preventing access to unscanned external devices and creating virtual VPN networks, restricting access based on media access control MAC addresses, backing up the user data to the clouds, and investing in robust and up-to-date network security technologies. These are all some of the key and important strategies that could help and enhance improving the network security within this wide area and a wide range and industry of communication and networking within the field of computing. So with that, I conclude my video series here. If you think this video series have been informative, so please do like, share, and subscribe to my channel. Thank you very much for watching, and thanks for your time.